Hi guys, this is your video for basic definite integrals. Up until now you've been learning about indefinite. Your answers have been polynomials, they've had x's in them. Now we are going to get values as our answers. So first thing we need to do is just need to remember, why are we trying to find integrals? You need to remember that definite integrals, that's helping us find the area under the curve. So what I've highlighted here is our area under the curve. We can find the definite integral. So for instance, if we knew what function this was, right now we don't, right? It's just a random one, I just drew it. So we can write this generally. I would write it using my integral notation. I can tell that my area is being cut off between the values of 2 to 7. And then I don't know my function. If I did, I would write that in there. And then always a dx. So that's how, if you are ever looking at a graph, trying to write this as a definite integral, it's the integral, and now we have these upper and lower bounds. You can see we have our lower bound is 2, upper bound is 7, and that means we started at 2 and continued till 7, and we're trying to find this shaded region underneath. So that is our goal. Remember why you're doing these problems, to find the area under the curve. So let's talk about how we can actually evaluate these definite integrals. So we know how to find the indefinite integrals. It's kind of like finding the antiderivative, and we always reference that as this big capital F. This means the antiderivative. So what you need to do is, after you do find your antiderivative, you're going to be plugging in your two values here. You're going to start with your upper bound, and then you're going to subtract whatever you get when you plug in your lower bound. So I plugged in F to my antiderivative, and then I'm going to subtract when I plug in B, A. Ooh, got really confused there. Plugged in B, subtract when I plug in A. All right, you know the deal. So let's look at an example. So you should already be fairly comfortable with finding integrals. You should be able to kind of remember the ways that you can rewrite. You should be able to remember the ways that you can find them. So one nice thing is that you don't need that plus c anymore. Even though these are technically indefinite for the time being, we don't need that plus c. We're going to have values. We're going to be plugging them in. So some notation that I always include are brackets. All right. When you're working on these, you want to make sure that you're including what the integral is in the bracket, and then we're still going to put those bounds on the end. So remember, to find integrals, you're going to add 1 to the exponent and divide by that same value. So this becomes x to the 5th divided by 5 minus 6x to the 4th divided by 4 plus 5x cubed divided by 3. So I've added 1 to each exponent, and I also divided by that same value. Now I am going to put my upper and lower bounds again. I need to remember that these are the values I'm plugging in. So let's just simplify it a little bit if we can, and then we'll plug in. So this is like 1/5 x to the 5th minus, let's see, we have 3x to the 4th over 2, and then this will just keep the same. Oops, over 3. All right, still going between 5 to 6. So now we are going to be plugging in. So I have my first term I'm plugging in is 6. So I have 1/5 times 6 to the 5th minus, I'm going to write this as 3/2 times 6 to the 4th plus 5/3 times 6 to the 3rd. Now, personally, I just ran out of room, so I'm just going to slide mine over. You do what you need to do in your notebook. And I'm going to subtract when I plug in my lower bound. So I have 1/5 times 5 to the 5th minus 3/2 times 5 to the 4th plus 5/3 times 5 to the 3rd. Hopefully you can see that. All right, let's get that in there. So I've plugged in my upper bound minus plugging in my lower bound. Now we actually have to solve these. So you can either grab a calculator, you can do it by hand, you can do whatever you need to do to solve for these. So when I do 6 to the 5th, I get 7,776, and I'm just going to divide that by 5. So over here I get 1,555.2. Now we're going to work on our next one. So we have 6 to the 4th, and then times 3 over 2, I get 1,944. And then I have 6 to the third, and I'm going to be multiplying that by 5/3, and I get 360. I'm just going to go through, just do all my exponents multiplying here. So now I have 5 to the 5th, and that's 3,125 divided by 5 is 625. Now I have 5 to the 4th, and that's going to be multiplied by 3/2, and I get 937.5, and then my last one is 5 cubed times 5/3. All right, so that's 208.33. All right, that's repeating. So now let's work on what we have inside of our bracket. So you see why the notation is very important here. You need to work on what you have inside of this bracket down to one value. Work on what you have inside of this bracket down to one value, then subtract. So we have 1,555.2 minus 1944 plus 360. So I have, whoops, let's put that pen back on. I have negative 28.8. And I'm going to be subtracting. Now I have 625 minus 937.5 plus 208.333. So now I'm going to be subtracting a negative 104.167. I had to round it off because it is a repeating decimal. So now we're going to add these up. So we have 104.167, and we're going to add it to the negative 28.8, and we get 75.367. So if your decimals are a little off, it's okay because this was a repeating one, but you can see that your step is the same. You're finding your general indefinite integral, then plugging in your upper bound, subtracting, and plugging in your lower bound. Your answers will always be values here. They're definite. We definitely know what the values are. So let's look at another example. So this one I'm going to go a little bit quicker because now that we've seen one done, we can do our antiderivative, which is our integral. So we're going to have x to the 4th over 4 minus 11x cubed over 3 plus 32x squared over 2 minus 28x. Always remember, if you had a constant, just tack an x onto it. And our bounds were from 0 to 1. Okay, so let's clean this up a little bit if we can. So we really have, I'm just going to leave it like this. So x to the 4th over 4 minus 11x to the 3rd over 3. This one can simplify to 16x squared, and this one cannot. 0 to 1. All right, now we got to plug these in. So with this specific problem, notice that our lower bound is 0. When I plug in 0, it's going to kind of just become one big 0. So we're not really going to see as much work as last time. So you're going to have 1 to the 4th over 4 minus 11 times 1 to the 3rd over 3 plus 16 times 1 squared minus 28 times 1. Now, really, we would be plugging in 0 here. And so you would have 0 to the 4th over 4 minus 11 times 0 cubed over 3, and so on. You're plugging in 0, it's going to be 0. So we have 1/4 minus 11/3 plus 16 minus 28 minus 0. Okay, they all became 0. And then we're just going to add these out. So I'm just going to use a calculator. I have 1/4 minus 11/3 plus 16 minus 28, and my solution, it's a repeating decimal again, so it's negative 15.4167. All right, so I'm actually going to change this problem. It's a little more advanced. We are going to learn that process probably next week or the week after, so don't worry if you missed out on that one. So here we go. We have an e to the x. e looks strange, I can promise you it's not. The integral of e to the x is e to the x, just like how the derivative of e to the x is e to the x. Way easier than this problem looks. So if you need a there we go. I wrote it on the wrong page. So the integral of e to the x equals e to the x plus c. Now we have it on the right page. So let's work on this. So we have to first find our integral. So we just talked about it. The derivative and the integral of e to the x is just e to the x. We do have these values that we're plugging in. So now we have to plug them in and subtract. So we're going to have e to the second minus e to the first. Now, hopefully you do remember that e is a value. E is a number. So you can use your calculator. You can estimate it, but calculator is nice and easy. So e to the second is 7.389. We're going to do 4 decimal spots. And then e to the first is 2.7183. We're going to round it to 4 decimal spots. Then you can just subtract. So we're going to subtract minus these together. So 7.3891. Subtracting it, and we get 4.6708. So 4 decimal spots. So e to the x was actually a lot easier than the last ones that we did. For that, you have your integral of e to the x. It equals e to the x plus c. Okay, so it's the same thing. Oops. So on to our last example for the day. Let me erase that mess that we had up there. That was for the last slide. All right, so sine of x. Okay, so again, it looks a little complicated. It's really not much more difficult than a polynomial. It's actually probably a little bit easier. So what you're going to do, all right, so when you're thinking about the integral of sine, think about what do you take a derivative of to get sine. Now the issue is that when we take the derivative of cosine, we get a negative sign. So that means our integral is going to be negative cosine. So it's negative cosine of x. Now we do still have our same upper and lower bounds. So this one's between pi over 2 to 3 pi over 2. And you may need your unit circle. If you don't, you can use your calculator. That's fine too. Just make sure it's in radians because this is in radians. But this is, you're going to see it's pretty easy. So we're going to be finding the negative cosine of 3 pi over 2. And we're going to be subtracting the negative cosine. You can see your brackets belong here. Negative cosine of pi over 2. So using your unit circle, remember that when you're looking at the values, it's cosine, sine. Like you look for your angle and then the end point is the value. So we're looking for cosine, so we're looking for the x value. Now the first one is going to be negative, and then the cosine of 3 pi over 2, so you go to 3 pi over 2, look at the x value. It's actually 1. Or sorry, 0. It's 0. And I wrote 0, I said 1. And then we still have our minus sign, and then we have negative cosine of pi over 2. So our cosine of pi over 2 is also 0. So it's minus 0. And no matter what signs you want to do, whatever operations you got going on, your answer is going to be 0. Okay, so your area between the curve and the x-axis would actually equal out to 0. So we are going to get into how this works, like how it does end up being 0, or maybe sometimes we have a negative area. That's not for today. Okay, today's practice is just taking the integral, plugging in your upper and lower bounds, and finding a value. So we do have one more. I just wanted to show you just the setup to how to get this organized. You want to split up your terms here. So when you get started with this, you're not taking the integral yet. So I'm leaving the sign there, and then I'm going to separate my terms here. So it's negative 10x over x squared plus 3 over x squared. And that's all with dx. Okay, it's a notation that needs to be there because that told us that we took a derivative with respect to x. So now we're going to take our integral with respect to x. Okay, so you can simplify a little bit if you'd like. So we have negative 10x to the negative 1 plus 3x to the negative 2 dx. Now it's kind of set up for us like a polynomial, and you can continue on the rest of the steps exactly the same. So you would continue. I'm not going to bore you and make you see it again, But please feel free to reach out if you have any questions. Use your other resources and materials that I've posted on your Google Classroom, and attend a Zoom workshop, a Zoom meeting, if you need any additional help.